Today what we're going to do is we're going to use both graphs and tables to determine Terrence's rate. And if you remember, Terrence was the skateboarder from the last lesson. And we just kind of described his pace by going fast, he's going slow, he's moving towards, he's moving away. Today we're actually going to get exact values. Okay, so as a reminder, describe Terrence's rate in words for each part of the graph. So if we have section A and B, A goes from one point to the other. Now, what is he moving? I'd say he's moving fast. And since the graph is going up, he's moving fast and away. So remember, if he's moving away from the detector, his feet is going up, so he's going up. If he was moving towards the detector, his graph would be going down. In part B, he's not moving. Whenever we have that flat line, he's not going anywhere because his distance is not changing on the y, but time does not stop, so therefore it is going to continue to draw that line. When we find our numerical rate of change, all we're going to do is count. So I'm going to give you a few points on that same graph we just kind of talked about. I'm going to give you these points here, and I'm going to then tell you they're approximate. But what the table would look like. Your first point is 0, 1, and if you remember, it's this point here, which means that he started 1 foot away from the motion detector. And then we have 2, 4, 4, 7, 6, 7, 8, 7, and 10, 7. Okay, so that's what all those points are on that graph. What we're going to do is find the rate of change from 4 seconds to 10 seconds. So how fast was Terrence actually moving during that time? Okay, so how we do that to find the rate is we do these things called jumps. Okay, and you do it from one entry to the next. So you ask yourself, how do you get from 4 to 6? Well, we would add 2. How do you get from 6 to 8? Add 2. 8 to 10? Add 2. Over here from 7 to 7, you would add 0, add 0, add 0. Okay? When we find the rate, we do this thing called change in y over change in x. In this example, it's change in our distance that he has traveled over our change in time. And that little triangle represents the word change. So if you see that, it just means change. Okay? Our distance, if one's x, one's y, our distance is this side. So our change in distance in this case was 0. We can say 0 because they're all the same. Over our change in time, and we're looking at every 2 seconds, 2 seconds in 2-second intervals. So in this case, he traveled 0 feet per second, once you have simplified. If we take a look at the first 2 seconds, or 4, I'm just going to look at the first 2. We still have to do those same jumps. So from 0 to 2 is plus 2. From 1 to 4 is plus 3. So to find the rate of change in this first section of the graph, we would say his change in distance was 3, right? And his change in time is 2. So he traveled 3 feet for every 2 seconds. And that's his rate of change. Will a horizontal line always have a rate of 0? And the answer is yes. So in summary, to find the rate from a table, we do the change in distance, which was our y value, divided by the change in time, which is your x value. So to find the rate from a graph, so if we were to look at the graph and find the rate, not the table, we would do the same thing. Many of you have heard of rise over run. Okay? However, we can just go up and over. Rise over run, up and over. So we're going to look at a different type of graph. The first graph we looked at went up and then stopped. So we had a positive slope. Now this graph we're going to say goes down. Okay, so when a graph goes up, we have a positive slope. When a graph goes down, you have a negative slope. So here's your values. I'm sorry, in this one, the line is decreasing instead of increasing. And here's our values. So at 0, they start 8 feet away from the motion detector. At 4 seconds, they're 6. At 8 seconds, they're 4. And at 10 seconds, they are 3 feet. So let's find the rate of change twice. Let's go between the first 2 entries and the last 2 entries of our table. So how do you get from 0 to 4? You would add 4. How do you get from 8 to 10? You would add 2. To get from 8 to 6, you now subtract 2, and from 4 to 3, you would subtract 1. So let's look first at our top values. So again, remember, it's change in y over change in x. Your x always comes first, then your y. So your change in y is this value here, which would say -2. Change in x is the one on the left, which is 4. Always, always, always remember to simplify your fraction. So you would say -1/2. So if we do the same for the bottom values, you would have the change in y, which is -1, and the change in x, which is 2. Notice how they simplify to the exact same value. This means that Terence's rate is constant. So we would say yes, because the rate is the same. Okay, so given this graph here, which segment shows a rate of change that's 0? So if you remember, anytime we have that flat line, it's not moving, or the object's not moving, Terence is not moving, so it would be 0. Segment A shows a negative rate of change, because notice your graph is going down when you're moving left to right. And segment C is positive because it's increasing, going up from left to right. So to find the slope or the rate of change in A from a graph, we have to get to this point, to this one. So we're going to move along our graph down and over. So we have moved down 1, 2, 3, 4 units. And since we moved down 4, it would be a -4. And then to the right 2, so that would be +2. So for the first 2 seconds, Terence was moving down 4 over 2, which simplifies to -2 feet per second. And all this means is that Terence was moving 2 feet towards the motion detector every second. The same thing we need to do for part C. We need to get from point A to point B. Since this graph is increasing, we know our slope is going to be positive. So here we're going to go up and over. So we went up 1, 2 units, and to the right 1, 2, 3, 4, 5 units. So this one we would always do our y value first, then our x value, rise over run, 2 over 5. This is a different type of graph that we are going to study next semester, but I wanted to show you the difference between a constant rate of change, which notice our graph always was very sharp, okay? Well, you can't have that, but all the lines were very sharp and straight. Notice this one has a little curve. This rate is not constant because it forms a curve instead of a straight line. Okay, and again, we're going to go over this next semester, but if in any graph you see a curve anywhere in the line, it is a not constant rate. So section A indicates that the rate of change is 0 feet per second. Remember we said that if it's flat-lined, it's not moving. B indicates a rate of change that is constant because it's that nice sharp straight line, and is negative because it's going down. Section C is also constant, but is positive because it's going up. D, on the other hand, has that little curve at the top, so it's not constant. but positive. And E, again, is not constant because it starts with the curve, and negative. So according to the graph, Terrence was moving faster during the time represented in B than C. So faster because we see that B is a lot steeper than C, knowing that he is moving faster. 8 did not show up on your packet, so we're just going to skip that one. For 9, we're going to find the rate of change of this graph. So we draw our lines connecting the two dots. We first move our rise, which would be -1, and our run is 5 units. So again, change in y over change in x. You cannot simplify -1/5, so that is your answer. Same thing here, move your dots or connect your dots. Here we moved down 2 units and to the right 4, rise over run. Since you can simplify this to -1/2, that is going to be your answer. And then lastly, number 11, connect your dots. We moved again down 3 and then over 1. So rise over run. If you just want to put -3, that's fine. For problem number 12, I give you the formula to fill out the rest of the table. So we're looking for y when we change our x value, and our x value is found right here on the left side of the table. So 4 times -2 is -8. -8 minus 5 is -13. So if you were to continue to change your values within here, we would have -1, which would give us -4 minus 5, which is -9. Your graph would look something like -9, -5, -1, and 3. So the rate of change, you again find your jumps. From -2 to -1 is +1, -1 to 0 is +1, 0 to 1 is +1, 1 to 2 is +1. -13 to -9 is +4, +4, +4, and +4. So our rate of change would be our change in y over change in x, which gives us a rate of change of 4. So what pattern do you see between your equation table and the rate of change? If you notice that all of them contain the number 4, you are correct. Okay? In your equation, the value that sits next to the x is always going to be your rate of change. So the rate of change here, instead of filling all of this out, which you're going to have to in your homework, we could just say is 2/3. The rate of change here is going to be -2. And that's all I have for you today. Your homework is worksheet 3. Good luck.